So today we are going to be looking at momentum in a different way. We're not just going to calculate out just straight momentum of an object. Today we're going to be looking at changes in momentum, specifically the law of conservation of momentum, which says that the momentum essentially before an event or before a collision must equal the momentum after collision. For this, direction is going to be really, really important. So I have a kind of a situation kind of set up here. We're going to say that this person on a boat has a mass of 76 kilograms. And he was starting off, he was standing on the boat and he's stepping off of it onto the dock. And the boat has a mass of 45 kilograms. So starting off, what I would call the initial velocity for these two, before the person steps off the boat, initially, neither of them were moving. So initially, they have a velocity of 0 meters per second. Once, he kind of steps off, the person has a velocity of 2.5 meters per second. In this case, we're going to say that's to the left, okay? So I can either say to the left is my positive or that's my negative. So I would say to the left, if I can quit messing with stuff here. Let's just say that the boater is moving in the negative direction. So we're going to put a little negative sign. Actually, let's just completely erase this stuff. And we're just going to call that negative 2.5 meters per second. So in this case, he's stepping off that way. And what we're going to find is that the boat is going to move to the right. It's going to have some velocity in the positive direction. I'll put a positive there. And our big question, the big thing we're trying to figure out is exactly how much velocity does that boat have? So the law of conservation states that the amount of momentum we have at the beginning is equal to the amount of momentum we have at the end. So if I'm looking at kind of total velocity here, I know that momentum is equal to mass times velocity. So in this case, if I'm looking at how much I'm starting with, we're going to go with the mass of the boater plus that's really not going to work, is it? Plus the mass of the boat times the velocity, which we know the velocity is 0 meters per second. So in this case, mass of the boater we said was 76 kilograms. Mass of the boat we said was 45 kilograms. Here's a big kicker though, that starting velocity for both of them was 0. So it means my actual starting momentum here is 0 kilogram meters per second. So that's easy. P1 is 0. That means my ending momentums, my P2, so one way to look at it is rather than put in P1, we could put mass of the boat times the velocity, the initial velocity of the boat, plus the mass, that was of the boater, plus the mass of the boat, times the initial velocity of the boat. Has to equal, because essentially this should really say like the sum of the momentum should equal the sum of the momentums at the end. All right, so kind of bumbled my way through that. But let's keep going. So this is all my P1 part, okay? That all has to equal the mass of the boater times the final velocity of the boater plus the mass of the boat times it by the final velocity of the boat. We already figured out this part. We took care of that up here. We figured out this side of the equation is just 0 kilograms per meters per second. do one of those, okay? So now I need to fill in the stuff I need to do over here. So the mass of the boater was 76 kilograms times the final velocity of the boater. In this case, we said that was negative 2.5 meters per second, plus the mass of the boat. We said that was 45 kilograms times the final velocity of the boat. And that's what we're looking for, all right? I want to know the direction I do want to know the direction the boat's going in. I already kind of know that intuitively. The big thing, though, is I want to know how fast that boat's going as this person steps off the boat. Thank you, Flipboard. So now I just need to do some pretty basic algebra just to get the final velocity of the boat. I could put commas here, I guess, by itself. So let's start off by taking 76 times 2.5, or negative 2.5. 76 times, what was it, 2.5 negative. All right, so I have, coming over here, 0 meters per second is equal to negative 190. Oh, sorry, that's not meters per second. That's kilogram meters per second. Okay, we said that was equal to negative 190 kilogram meters per second plus 45 kilograms times the final velocity of the boat. All right, so now basic algebra, I need to get this over here. To do so, I just need to add 190 to both sides. So I have, if I can quit scrolling, 190. So yeah, because adding 190 just gives me 190 kilogram meters per second over here. Then I'm left with 45 kilograms times the final velocity of the boat. All right, so now I still need to get VF of the boat by itself. It's being multiplied by 45 kilograms, so I just need to do the opposite, which is divide by 45 kilograms. All right, so VF of the boat is equal to 190 divided by 45. And I got 4.22. That should be, let's see, kilograms cancels kilograms, meters per second. And in this case, it is kind of important that I list the direction. So if we're say that the boater, the person is stepping to the left, I need to indicate that the boat will be moving with a velocity of 4.22 meters per second to the right. So I'm on a boat. I get off the boat at 2.5 meters per second. Okay, that's how my velocity. That boat kind of gets pushed away from me because essentially whatever momentum I have to the left, that boat has to have that same amount of momentum to the right. And if we have different masses, we end up with different momentums. Another way to kind of look at this mass velocity thing is the smaller the mass of the object, the faster it has to go to kind of maintain that momentum. In this case, there are some other questions like this where really the big takeaway, the big thing that you're going to want is this part right here, which we're going to rewrite that a little bit. So really we're going to stick with P1 equals P2. Nearly P1 can be written as the mass of object 1 times the velocity of object 1. Actually, let's make that the initial. The initial velocity of object 1 plus the mass of object 2 times the initial velocity of object 2. We'll put commas here. Okay. Is equal to the mass of object 1 times the final velocity of object 1 plus the mass of object 2 times the final velocity of object 2. This right here is kind of the big key to what we're doing. Really just because that part's all takes care of my momentum at the beginning. That part's my momentum at the end. And really, we're just got to set these things equal to each other, and then just solve for the variable we know. I know I stuttered and kind of bumbled my way through that, but we got through it. I'm hoping that's enough to get you guys through the practice problems. I'm around for questions.